All right, so we are going to be taking notes now on solving trig equations. So in order to solve a trig equation, you're going to need to do the same thing you do to solve any algebraic equation. So I've given you these 4 equations to solve. What would really be the best thing for you right now would be to pause the video, try solving these. All of these are ones that you've solved in Algebra 1 or Algebra 2. And then when you're finished, check with the video and see if you did it correctly. Hopefully you did. All right, so for this first one, in solving for x, I'm going to subtract 1 from both sides. And I end up with x equals -1. For letter B, I subtract 1 from each side. And I get 2x equals 4. Then I divide by 2, and I get x equals 2. For letter C, I subtract 5 from both sides, and I get x squared equals 2. Excuse me. Then I take the square root. Now, this is really critical here. Because I took the square root, I have to remember the plus or minus the square root of 2. That means there's 2 solutions, positive square root of 2 and negative square root of 2. It might not seem like a big deal, but each solution counts the same amount. So if you only give one of them, it's like you get a 50%. On a problem like letter C, especially when we get down into the trig equations. So you've got to remember the plus or minus. If you take the square root, you don't know which solution I want, the positive or negative, so you have to give both. When we were using law of cosines, you didn't have to say plus or minus because it was the length of a side, which means that it had to be just the positive solution. All right, letter D, there's many ways to solve a quadratic. You can graph it and find the solutions. You can use the quadratic formula, or you can factor. I'm going to factor this one. When you factor, this is where you put the product here and the sum here, a product of 6 and a sum of 5, and 2 and 3. When you multiply, give you 6. When you add, gives you 5. So this is x plus 2 times x plus 3 equals 0, which means one of these factors has to be 0. The only way to get a product of 0 is for you to multiply by 0. So either x plus 2 equals 0 or x plus 3 must equal 0. Subtract 2 from each side, x equals -2, and x equals -3. You need to know how to do these 4 equations in order to be able to do what we're doing here. So we're going to take equation solving, and we're going to merge it with the unit circle, and that's going to give us trig equations. So let's start with number 1. We are given the equation sine of theta equals the square root of 3 over 2. I'm solving for theta, so I take the inverse sine of each side. Now, I added in the inverse. The inverse was not there, so I want all possible solutions. So when you're solving an equation and you have the inverse, that doesn't mean we have a restricted domain, because I'm saying I want all possible thetas between 0 and 2 pi. Everyone on the unit circle that has a sine of square root of 3 over 2. Not just that right side. If I give you a problem that simply says what is the inverse sine of the square root of 3 over 2, you would only give me the one answer, which is pi over 3. However, when you're solving an equation and you put in the inverse, that means I want all possible solutions where sine is the square root of 3 over 2. So I go to my unit circle, here a little bit so I can see the whole unit circle, and I want all the times that sine, which is my y coordinate, is the square root of 3 over 2. So it happens here at pi over 3. It also happens here at 2 pi over 3. It's not going to happen anywhere else. Here it's going to be negative, and here it's going to be negative. So it happens at pi over 3 and 2 pi over 3. So theta equals pi over 3 and 2 pi over 3. If you only give me one solution, you only get half the credit. You need both solutions. When you're solving an equation, notice they're saying all solutions between 0 and 2 pi. Most people like this better because now we get to just use the entire unit circle and give all possible solutions from the whole unit circle. Let's go to number 2. Cosine of theta is negative 1/2. We want to solve for theta, so we're going to take the inverse. Now the inverse wasn't there. It's not like this where it was there from the start. We added it in. Therefore, we have to find all the times where the cosine is negative 1/2, where the x-coordinate is negative 1/2. So I go to my unit circle, and I look for x-coordinates. Right there, there's an x-coordinate that's negative 1/2. 2 pi over 3, that's one of my answers. Keep going. Oh, it happens again right here at 4 pi over 3. So at 2 pi over 3 and 4 pi over 3. So theta equals 2 pi over 3 and 4 pi over 3. Let's go to number 3. Tangent of theta equals 1. Take the inverse of each side. Theta equals the inverse tangent of 1. Where on my unit circle is the tangent 1? All places between 0 and 2 pi. As you can see, it's normally happening twice. And notice they're always in the same family. Pi over 3, 2 pi over 3. 2 pi over 3, 4 pi over 3. It's got to be in the same family. Either pi over 3, pi over 4, pi over 6, or the four corners. So where is the tangent positive 1? Okay, so I'm looking at the outside. Right there, a pi over 4. So now I know it's got to just stay with my pi over 4. So let's look. Oh, it's negative there. It's positive here. So at pi over 4 and 5 pi over 4. Over here it's negative. So at pi over 4 and 5 pi over 4. So that's kind of like the first stage of equation solving. Now we're going to go to a little bit more advanced, kind of like these problems were right here were sort of like letter A. One step. Do one thing, and then you get your answer. Let's go to numbers 4 and 5. 4 and 5 are pretty similar types of problems. So I need to solve for theta, so subtract 6 from both sides. And I get 4 times the sine of theta equals negative 2. Divide both sides by 4. And I get that the sine of theta is negative 1/2. So to solve for theta, I need to take the inverse. What I did here was I took the inverse of each side. These canceled, and I was left with theta equals the inverse sine of -1/2. Where on my unit circle is the y coordinate -1/2? Go to my unit circle. I see that it's +1/2 here on yellow, which means yellow is the color I'm going to want to stick with. It's +1/2 over here. Here it's -1/2, and here it's -1/2. So at 7 pi over 6 and 11 pi over 6. So theta equals 7 pi over 6 and 11 pi over 6. Let's go to number 5. Subtract 1 from each side. Negative cosine of theta equals 1. Divide by -1 to get rid of that negative. Cosine of theta equals -1. Take the inverse of each side because I want to find theta. Theta equals the inverse cosine of -1. Where is my x coordinate? -1. It's +1 here. Oh, it's -1 right there. That's the only time right there at pi. So theta equals pi. And that's the only answer for that one. All right, now we're moving on. So these three were kind of like our letter A up here. These two were like our letter B. These next couple are going to be like our letter C. All right, I've got tangent squared of theta equals 3. That means I've got to take the square root. Well, as soon as I take a square root, I have to remember that the tangent of theta equals plus or minus the square root of 3. Well, since it's positive or negative, that means any time the tangent square root of 3, it can be plus or minus, which actually kind of makes it easier to find it. I don't have to worry about the positive or the negative because I want them all. So where is my tangent, the square root of 3? Up here, right here, which means on all of my blues, because it's positive here, negative here, positive here, and negative here. See, square root of 3, negative square root of 3, positive square root of 3, negative square root of 3. So all of my pi over 3's. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. My entire pi over 3 family. Let's go to number 7. I don't know if we'll be able to finish it. I think we're going to stop right there, and I'll pick up with 7 in the next video.